So people ask me, how do I know what the pressure is if I go deeper and deeper into a fluid? In this video, I'll show you a very quick way to assess what the pressure will be. So here we have an example. We've got some beaker, and in this beaker, we've got a point up on top. This is P1. We're going to find the pressure at P1. And then we've got a point at P2 that's underneath a distance h of fluid. Well, the pressure at P1 is just the atmospheric pressure. So if you're right on the top of the fluid, all you have is the pressure of the atmosphere. So that is known to be 101 kilopascals, where Pascal is a Newton per square meter, and kilo is 10 to the third. But what about down here in P2? P2 has all this fluid that's on top of it that's pushing down on it. And so the pressure on P2 is the same as pressure on P1, that's 1 atmosphere, plus the column of fluid that's on top of it, which is given by rho times g times h, where rho is the density of the fluid, and g is just 9.8 meters per second squared, and h is this distance here in meters. And by the way, the density of water is 1,000 kilograms per cubic meter. So as you can see, as you go deeper and deeper in the fluid, or if the distance up to the top, the height gets greater and greater, the pressure will become increasing. This is something we intuitively know. If you dive into a pool and you go to the bottom of the pool, you feel increased pressure on your sinuses. And as you go up toward the top, you feel less pressure. The same can be said about airplanes. You know, when you fly up in an airplane, even though the cabin is pressurized, it doesn't fully compensate for the loss of pressure as you go to higher and higher altitudes. So you're less deep in the fluid, quote unquote, of the air. And likewise, when you come down from altitude, you can feel increasing pressure, and so that you can hear popping sounds in your ears. So that's it. It just depends on the depth that you're in, or the height up to the surface of the water, plus the atmospheric pressure. Hope this was helpful. And it's brief.